Next problem based on Central Limit Theorem. The lifetime of a certain brand of a electrical bulb may be considered as a RV with mean 1200 hours and standard deviation 250 hours. Find the probability using Central Limit Theorem that the average lifetime of 60 bulbs exceeds 1250 hours. Given population mean, that is mean, right, electric bulb life, right, mu is equal to 1200, then population standard deviation sigma is equal to 250, then sample size, they are taking 60 bulbs, right, so small n is equal to 60. To find probability of average lifetime of 60 sample bulbs exceeds 1250 hours, that is to find probability of sample mean x bar exceeds 1250 hours, that is x bar is probability of x bar is greater than 1250, subtracting mu on both side, right, probability of x bar minus mu greater than 1250 minus mu divided by standard error sigma by root n, so on both sides, so probability of x bar minus mu by sigma by root n greater than 1250 minus mu by sigma by root n. So we know test statistics z is equal to x bar minus mu by sigma by root n, so this becomes probability of z greater than, and substituting the value of mu and sigma 1250 minus 1200 divided by 250 by root 60, right, that is probability of z is greater than 1.5492. so the area above the line z is equal to 1.5492 in the normal curve, right, z is equal to 0, z is equal to 1.5492. our probability area is this side above that. So dark blue shaded area, so we know left side of z is equal to 0, the total area is 0.5 and right side area is also 0.5, right, total area of normal curve is 1, so left side of z is equal to 0, that is negative side and positive side each 0.5, because normal curve is symmetric, so the total area to right side of z is equal to 0 is equal to left side of z is equal to 0. So total area greater than 1.5492 is the right area, total right area 0.5 minus area between z is equal to 0 to z is equal to 1.5492. So 0.5 minus right area total area 0.5 minus area between z is equal to 0 to z is equal to 1.5492. So that is equal to 0.5 minus probability of 0 less than z less than 1.5492. From the normal table the value is 0.4392. So 0.5 minus 0.4382. So the probability is 0.0618. Next problem, a distribution with unknown mean mu and variance equal to 1.5. Use Central Limit Theorem to find how large a sample should be taken from the distribution in order that the probability will be at least 0.95, that the sample mean will be within 0.5 of the population mean, right. So given population variance, they have given variance equal to 1.5, sigma square is equal to 1.5, so standard deviation, population standard deviation sigma is equal to root of 1.5, that is equal to 1.2248. now population mean equal to mu, sample size is n, right, to find the sample size n such that the probability that the sample mean x bar will be within 0.5 of the population mean mu is at least 0.95, that is what they get given, right. So to find the sample size n such that the probability that the difference in sample mean x bar from population mean, that is x bar minus mu, right, is at least x bar minus mu within 0.5 is at least 0.95, right. So to find n such that, so distance between the difference means modulus x bar minus mu, which is less than, within 0.5 means less than 0.5. So total probability of x bar minus mu less than 0.5. It at least means minimum 0.95 and maximum, so any number, right? So greater than or equal to 0.95, right? Any number means in between 0.95 to 1, whatever it is, right? So now probability of modulus x bar minus mu less than 0.5 greater than or equal to 0.95. So we know modulus of x is less than a means minus a less than x less than a using modulus definition. So here probability of minus 0.5 less than x bar minus mu less than 0.5. We have removed a modulus. Instead of modulus, we are writing in the inequality, which is greater than or equal to 0.95. So probability of minus 0.5 divided by sigma by root 10 less than x bar minus mu by sigma by root 10 less than 0.5 by sigma by root 10 divided by sigma by root 10, right? Greater than or equal to 0.95. We know z test statistics, which is equal to x bar minus mu by sigma by root 10, and substituting the values. So probability of minus 0.5 by sigma by root 10 less than z less than 0.5 by sigma by root 10 greater than or equal to 0.95. So value is sigma is 1.2248, n we don't know, right? So minus 0.5 by 1.2248 within probability, right? Root 10 less than z less than 0.5 divided by 1.2248 root 10 greater than or equal to 0.95. That is, you can denominator that is reciprocal of that, right? It will go to the numerator. So probability of minus 0.5 root 10 divided by 1.2248 less than z less than 0.5 root 10 divided by 1.2248, which is greater than or equal to 0.95. So area between, this is nothing but area between z is equal to 0.5 root 10 divided by 1.2248 to z is equal to 0.5 root 10 1.2248, which is greater than or equal to 0.95. So this area can be splitted into minus to 0, 0 to plus, right? So this can be written as area between z is equal to minus 0.5 root 10 1.2248 to 0, because in between 0 is there, the line 0 is there, right? Plus area between z is equal to 0 to z is equal to 0.5 root 10 1.2248, which is greater than or equal to 9.5. So that is probability of minus 0.5 root 10 1.2248 less than z less than 0 plus probability of 0 less than z less than 0.5 root 10 by 1.2248, which is greater than or equal to 0.95. So this is the one, this is z1, that negative value 0.5 root 10 by 1.228. This is the positive value 0.5 root 10 by 1.228. So yellow shaded area is the required area. So this area is equal to this area, right? In normal curve it is symmetric. So we are using that property. So this implies 0 probability of 0 less than z less than 0.5 root 10 by 1.2248, because instead of minus 0.5 root 10 1.2248 to 0, that area is equal to 0 to plus 0.5 root 10 by 1.2248. So we are using that idea, which is greater than or equal to 0.95, right? So z is equal to 0, this is negative area, this is the positive area, right? So 2 times probability of 0 less than z less than 0.5 root 10 by 1.2248 greater than or equal to 0.95. So probability of, we are bringing that 2 to the right hand side, probability of 0 less than z less than 0.5 root 10 by 1.2248 greater than or equal to 0.95 by 2, that is equal to 0.475. So 0.5 root 10 by 1.2248, which is equal to 1.96 from the normal curve table, right? So if the probability value is 0.475, then the value is probability of 0 less than z less than some number, right? Less than, suppose you take that number is a, which is greater than or equal to 0.475 means you have checked the normal table. So greater than 475, you take the numbers, right? 0 to that particular number, that number is 1.96, right? So cross multiplying 0.5 root n is equal to 1.96 into 1.2248, 2.4006. So root n, which is equal to 2.4006 divided by 0.5, 4.8012. Squaring both sides, n is equal to 4.8012 square, that is 23.052, approximately 23. So sample size should be 23. Thanks.